All right, so here's our practice question for an electrolytic cell. So we want to draw an electrolytic cell that would be able to plate nickel onto an iron drill bit. And we need to have these things in our diagram. We have to have the electrolyte solution and label its contents, an anode, cathode, power source, and the direction of the electron flow. Well, first off, I guess we can start drawing our container. Now remember, an electrolytic cell, we don't need a salt bridge. All the electrodes are in the same solution. So if we need to plate our iron drill bit, then our iron is going to have to be one of our electrodes. And if we're going to be plating a solid onto it, it better be the cathode. So the iron is going to be our cathode. So that's one way to remember what's happening in these. Our cathode is always going to be plated or covered with the solid. All right, so we're also going to have an anode. We're going to have a solution, some liquid here. Because it's an electrolytic cell, we have to have a power source because we're going to be forcing a reaction that would not normally happen. It's non-spontaneous. It's not the spontaneous reaction that would happen. Okay, so we're going to have a power source like a battery here. Now, we know if we have a cathode, we also have to have an anode. So we can write that in without even knowing what reactions are occurring. And we also know that electrons always move from A to C, anode to cathode. Doesn't matter if it is a voltaic cell or an electrolytic cell. They always have to move from anode to cathode. So that's the way the electrons are going. So we've done electron flow. We've written our power source. We know the cathode. Let's figure out what our anode and what the solutions are here. So in order to actually plate nickel onto something, we better have some nickel ions somewhere. So we're going to have some nickel ions in solution. Nickel is 2 positive. All right, so where are these nickel ions coming? Well, they're probably coming from our anode. So we're going to have a nickel solid over here. So as the electrons are drawn away from nickel, okay, they're heading towards that power source. Every time you lose an electron from nickel, you're going to gain an ion. So you're going to have nickel solid losing an electron, so going through oxidation, and actually 2 electrons because nickel is 2 positive. All right, now if we're plating nickel onto iron, then we're creating solid nickel here. So our nickel ions are picking up the electrons and plating on top of the iron. So we have nickel ions from the solution. They came from there. They're now going on to here, and they're picking up the electrons and forming nickel solid on top of our iron here. So now well, it won't be up there. It'll be down here under the solution. So there we have nickel solid being plated onto our iron. So nickel ions are gaining electrons, so they're being reduced. Now remember, reduction happens at the cathode. Remember, you can remember the gain electrons reduction cathode, the jerk, and at the anode, you're losing electrons oxidation at the anode. All right, so we've identified our anode, and our electrolyte solution is going to have nickel ions in it. There we go.